Okay, good afternoon. My name is Joe Cho. I am a technical account manager at AWS. And I'm absolutely delighted to be joined by my partners from the New York Stock Exchange, Anand Pradhan, Senior Director, and the Head of the Regulatory and National Market System Technology at the New York Stock Exchange, and also Vinil Vandari, Director of Engineering at the New York Stock Exchange. And also, I see quite a few people from the exchange here. Welcome, welcome, all of you. Now, it's already Thursday. Sadly, we're already at the tail end of reInvent. And we heard many exciting announcements, inspirations. I mean, honestly, I can't wait to go back and try so many things that were announced. But I'm really excited about our session today, as many of those enablers that were announced this week, that were discussed, we use it here to solve and address a very pertinent problem that I believe is fundamental to the way we live. There we go. So we'll be talking about trade surveillance, what it is, because I think sometimes we as engineers, we like to just dive in and write code. But I believe we need to understand the business problem at hand. And the deeper we understand the problem, the better we understand, the better we are able to create our solution, our product. And we'll be talking about the Intercontinental Exchange, ICE, and the New York Stock Exchange, the builders of this system. Because as you've seen, technology is not just servers and code and IP addresses, it's people, the builders such as yourselves. And then we'll be talking about the challenges of this business problem, trade surveillance, the sheer magnitude, the scope of it, how it impacts us all. We'll talk about the cloud migration journey that the New York Stock Exchange took to bring this workload to the cloud. Some of the initial thought processes, the decision points, as well as the challenges that we faced, and then how we overcame them, and how we are looking forward. And we'll be talking about optimization. Because once you're in the cloud, you have all this, one of the fundamental aspects of the cloud is you pay for what you use. So we'll discuss in detail where and how we optimize, what buttons and levers we press. And then, as we heard from this morning, from Warner's keynote, you evolve or you die. So we are very proud of what we built here, but we don't want to just sit back and relax. We want to see how we can move this forward. And once you're in the cloud, all these new avenues open up to us, how we can build upon it, add value to what we have already built. So we'll be sharing some of our thoughts on how we can move this workload even further. And finally, we'll be discussing the takeaways, lessons learned, so that you too can learn from our insights. So trade surveillance, what is trade surveillance? I'll be discussing a bit at a high level, and then Anand will be discussing a bit more detail. But I don't think it's an exaggeration when I say this is something that impacts us all, whether we know it or not. Whether you're a trader or a banker or an engineer or a doctor or a teacher or a student, it's fundamental in society, how civilization works. Now, a few months ago, Anand and Vinil, they invited me to a lunch at the 1792. Absolutely, it's an exclusive restaurant with the New York Stock Exchange. Wonderful establishment. Thank you so very much. It was a great meal. Now, when I walked in, the first thing that caught my eye was this absolutely gorgeous mural on the wall. And Vinil explained to me what this mural depicted. It was the Buttonwood Agreement, which, as I understand it, was when the first of the early New York brokers, merchants, businessmen got together and signed a bunch of rules and regulations and processes. And it is this establishment that helped the community to grow and prosper. And this community is what we now call Wall Street. So trade surveillance protects this community. It keeps trust in the markets allows the global financial organization to function. Now, over here on the screen, you see some words that I'm sure you've seen in the news at times, where some of the bad actors, they try to abuse the markets. And if you think about what a surveillance system that are watching these things needs to do, it needs to monitor every single trade, it needs to analyze them, and it needs to do it in real time. And when you think about that, the sheer scope and the size of this work, it's mind-boggling. And the New York Stock Exchange, being the largest exchange in the world, bears much of this responsibility. So without further ado, allow me to ask Anand to come to the stage.
Thanks, Joe. That was some introduction for us. Over this week, we all learned a lot about new technology, new initiatives. However, the story that we are going to share here is equally important and meaningful. But before I start, I'm Anand Pradhan, a Senior Director of Technology at New York Stock Exchange. I have over 20 years of experience in technology and have been associated with New York Stock Exchange since 2007. I have played pivotal role in many of the technology migration and modernization at New York Stock Exchange, including our low latency flagship trading platform NYSE pillar. Among other things, currently I head to diverse technology department. One of the department deals with low latency, high throughput market data consolidation system. We provide technology for CTA and OPERA. CTA is the market data consolidation engine for all US equities exchanges, and OPERA is the corresponding one for all options exchanges in the US. To give you some perspective, OPERA handles 100 billion messages between 9:30 a.m. and 4 p.m. with 20 microsecond latency. I led the team to migrate both these systems to Pillar technology recently. The other department that I had provides technology for NYSE regulation, and the biggest system we have there is NYSE surveillance. We recently migrated that to the cloud, and we are here to learn more about that and the architecture and the story of the migration. We at New York Stock Exchange are very proud of our flagship technology, NYSE Pillar. We have spoken about it multiple times, but we are equally proud about our migration to the cloud. I led the team to migrate that to the cloud, and that is our first full-blown application running in the cloud for NYSE and ICE. So let's take a look how the application looks like. But before we look at the application, we should understand what the organization does. Intercontinental Exchange, or ICE, is a global financial organization with operating exchanges, clearing houses, data services, and mortgage technology. ICE makes opportunity a reality. ICE builds connection between data and technology, between innovation and expertise, and ultimately between people and opportunity. In ICE and at NYSE, we help established companies and startups of tomorrow to raise capital so that they can change the world. New York Stock Exchange, under the ICE umbrella, is the largest stock exchange in the world. We have 5 equities exchanges and 2 options exchanges. We trade more than 12,000 equities and ETF, and we trade more than 1.6 million option series every single day, and the number keeps growing day after day. Now, Joe gave a high-level introduction of surveillance and trade surveillance, but I would touch upon a little more to explain what it means. So we operate self-regulatory organization, or in short, you can say SROs. We have rules. Rules are approved by SECs. The firms who are trading need to abide by the rules. And in order to make sure that the rules are followed, we need to look at each and every activity that happens in our exchanges. What it means is that every order that is placed, every fill that happens, every price quotation, every trading price movement that happens, we need to look at that. So what we do is that we take the audit trail data for each of these activities from our options exchanges, equities exchanges. We ingest that into the system in real time. However, only the data from our exchanges will not make the cut. So we have to look at the quotation or the price movement that is happening in other exchanges also. We take the market data. Along with that, we take various other data sources, and we mine the data, and we have threat scenarios defined based on the rules that we have. So we look at each of these things, and in order to manage these things, we have job scheduler running in real time and at the end of the day. The output of this one is some alerts and exceptions generated, which the NYSE regulation team looks at, analyzes further, and make decision based on that. So what are the challenges of a trade surveillance, right? If you want to know more, NYSE Exchange Group handled more than 500 billion messages in a single trading day. That's like 500 billion messages, right? Our consolidated market data system processes the data under 20 microseconds. Our exchange trading system processes the messages under 35 microseconds. Now, why am I telling these numbers, right? Because of all these activities, there is a dense nanosecond granularity time series data generated out of our exchange. Now, the surveillance system should be able to keep up with the pace and should be able to process all this data in real time and provide the output to the regulators so that they can manage and monitor the market. So, to give you some perspective, we get approximately 10 terabytes of compressed binary real-time data per day, and our problem doesn't end there. Because we work in a very regulated environment, and NYSE is at the center of the regulation. We have strict Reg SCI requirement by SEC. What it means is that we have to aim for 100% uptime. We cannot fail ever to monitor the market. And based on the rules, we have 300 distinct threat scenarios which are running. We have 25 distinct data sets that we need to consume every single day. So that's the challenge I'm talking about here, right? So it's not like before this system, we didn't have a system. We had a system which was doing its job, It was producing some reports, and, regulation team would look at it, manage the market. But operationally, it was very challenging for us to manage that system. Because the system is not only a transactional system, but a huge big data system. And trading system across the globe has become more sophisticated. New hardware, new infrastructure, new algorithms are coming. So the data that ends up in the exchange world keeps growing every single day. Then you have heard about meme stock activities. Sudden news comes about some company, and you can see some surge in activity. So we need capacity to handle all these surges that happen in our exchanges. During pandemic, our trading volume skyrocketed. So in order to keep up with all these things, we invested heavily in the on-prem infrastructure from time to time. So when we were looking at migrating this system to a better system, obviously we wanted to improve the performance of the system. Needless to say that the system needs to be scalable for compute as well as storage. One other thing I would like to touch upon, the previous system, once the data was processed, it was not easily accessible. You cannot query the data which was processed in any previous day. So we wanted to make sure that once we process the data, the analyst should have ability to query the data for any previous day. And I talked about Reg SCI requirement for failure recovery, And at any given point of time, we are very frugal about our migration, so we want to reduce the cost. So with that said, we started our journey to look at cloud as an avenue, right? Cloud as a tool, whether cloud can solve the problem that we are talking about here. So when I started looking at this problem, I saw that there is a huge amount of infrequently accessed data. Now, what it means is that there is 10 terabyte of raw data coming into the system. We process it, we produce a very small output, and the output is presented to the regulator, and they are doing some analysis. There is need for accessibility for the raw data, but it is infrequently needed. It's not like readily needed. The other thing I realized is that the requirement is near real time. So we had some cushion in terms of geographical latency that is there in the network to take this data from our data center to AWS's data center. One of the critical requirements that we noticed is that there is a demand for retro runs. Now, you might ask, what is retro run? So let's say some rule changes happen. So the parameter of the threat scenario needs to be adjusted, or there is a bug which is sitting in production. You need to patch it and then try to regenerate the alerts. So there is a need to rerun the load again on the data that is sitting. And there is a demand for elasticity here, right? Because right now we are processing the data for current production day, and we have to process the data for any previous day, which could be 6 months old, 3 months old. And at the same time, analysts are sitting there so they can query. So there is a demand for elasticity because of the number of parallel queries that can happen on the system. One other critical component I realize is that there is a huge amount of ingress bandwidth into the cloud, but the output that is generated is represented on the web dashboard as a report. So the bandwidth egress was very low compared to the ingress bandwidth. And as public cloud providers are not charging for ingress bandwidth, it was quite evident that cloud is the good use case. Now, when we were doing the cost analysis and we were looking at the problems that we had in the previous system, in order to have a system which could manage all this load, we had to put a large amount of CapEx. But with cloud, it's a manageable OpEx year on year. Then the last point that I saw is that one of the biggest financial regulatory organizations was already on AWS Cloud. So that was a good reference point for us for compliance and Reg SCI coverages. So it became no-brainer that cloud could solve this problem. Now, before we look deep down into the cloud architecture, I would like to walk through this business data flow and why we came up with this architecture. Now, on the left side, you see a set of boxes, which are basically showing some of the data sources. Like we talked about CTA and Opera for consolidated market data. Then we have pillar systems. We have reference data systems. And we have UTP-SIB, which is an external consolidated market data source for tape C securities. So data is produced over TCP/IP, multicast, file delivery, REST API, you name it, we handle it all. We at New York Stock Exchange run large-scale data centers. We know how to run low-latency network and infrastructure. So what we did is that we put collection servers in our data center, and we did what we do best. We absorbed all the burst that happens in multicast. We wrote the data to SSDs on those servers. And there is a feeder on the collection server, which has a TCP connection to a receiver, which is on the AWS side. It funnels the data there. And then the receiver is writing the data to EFS on the AWS side. From that point on, we have real-time data processors. And there is a query engine which is there. So they are doing their job with the job scheduler so that we can generate the alerts based on the threat scenarios. Then we have end-of-day processing that happens. And we have many more threat scenarios that run at the end of the day also. Now, the data which is produced as the output is again written to EFS. It is presented to our NYSE corporate network as a desktop representation. Now, if you look at here, this is a hybrid architecture. So we wanted to utilize the best of both the worlds. Cloud is good at elasticity. You can do big data processing with elastic computing. We are great at handling low latency, high throughput system. So we utilize that aspect of it. And that's why this design came into the picture. Without waiting further, I would like to introduce Vinil from my team, who was instrumental in handling the AWS architecture. Thanks.
All right. Am I audible enough? Good, good. OK, great. Good afternoon, everybody. My name is Vinil Bhandari. I'm the Director of Technology at NYSE. I've been in software development space for close to 2 decades now, different industries, different domains, varying from edtech to e-commerce to healthcare. And finally, I landed up in finance 3 years back. I've been working in the cloud development space since 2009, and I've worked with every major cloud provider that exists out there. Here at NYSE, we started our cloud journey about 3 years back when I joined the organization. Before I dive deeper into the architecture, I want to quote one of my favorite poets and playwrights from Ireland, whose death anniversary, incidentally, was yesterday, Oscar Wilde. He once said, "I have the simplest of tastes. I get satisfied by the best." So while building this platform, as we present our journey to you, we are very proud to claim that it is definitely state-of-the-art best platform that exists out there for surveillance. And we'll look at how we designed it, what are the pillars that we considered while designing this huge scale system. The 4 pillars that I'll talk about are storage. As Anand mentioned, massive, massive amounts of data, 10 terabytes of data a day. What kind of AWS services we leverage to host that data, read that data, write to the disks and whatnot. So that'll be the first pillar I'll touch on. Second pillar will be compute. What kind of compute capabilities that we were able to leverage from AWS and what we had to build in-house. The third would be, how did we do the orchestration of all this mumbo-jumbo in the cloud, and how do we keep the lights on today in the cloud and on our on the premises. And the fourth pillar would be, what is it that we learned while we embarked on this journey for the last 3 years, and what kind of lessons we've learned in this space, and what we have done with those lessons to optimize our footprint in the cloud. So this is part of our infrastructure in cloud. Everything that we do cannot be put in a single slide. So we are primarily based in US East 1, North Virginia. That's our primary region, with Ohio being the DR for any DR purposes. We leverage about 40 different AWS services to manage this platform, to build this platform. Our data is highly sensitive, regulatory, compliance-related data, so it cannot flow over internet. No. That would be too easy, right? And we don't like to do easy stuff. But we didn't know how hard this problem is going to be, to be honest. But while building, we learned that there's got to be a decent amount of encryption that needs to happen at rest as well as in transit. So things like KMS and TLS were extensively leveraged to take data from our on-prem assets to the cloud. Everything that we built in the cloud had to be elastic, right from the network tier to storage to compute, because the nature of our traffic is very bursty. One day, we might see 300 billion records. The very next day, it could be 500 billion. Everything that we leverage has to be in a state that can auto-heal or auto-recover. So the things that have never happened or probably have happened once in the history of AWS with S3, like once I remember, a regional outage happened with S3. We had to be prepared for a rare event like that as well. So auto-recovery as well as resiliency was a key. Because like Anand said, there are many industries out there where uptime is important. I've never seen anything like this that happens in exchanges where uptime really means uptime. There's no possibility of going down. Then we had to leverage a lot of IAM-based RBACs, because who has what control over what data had to be very minutely understood, set up, and then monitored as well. While doing all of this, we had to be very mindful of the cost. This was NYSE's first foray into this scale of cloud-based infrastructure. So we had to keep costs down while keeping single-digit millisecond latencies between on-prem assets and cloud. And lastly, the whole architecture was designed with the infrastructure as code in mind, which I'll touch upon a little bit more in detail. We were very excited, happy, and still reap the benefits of using AWS's beautiful service called CDK, Cloud Development Kit, if some of you have used, and along with some of Terraform. So at a very high level, that's the architecture. In the diagram, here is the receiver, which receives the data from our on-prem infrastructure, billions of records every day. That data through TCP connections is received on the disk and then eventually flows to EFS tier of AWS, Elastic File Service. We tried using S3 in the beginning, and then we realized that the kind of latencies, throughput, and I/O that we need, the solutions available at that time didn't really fit the bill, let's just say. So instead of using S3 directly, we had to bring in another really beautiful layer, and I guess some of the EFS folks are here in the crowd as well. Shout out to them for helping us with that decision, as well as our journey of using EFS. So this tier is EFS, and then once we've processed the data for today's date or for current date, we move all of that data to a cheaper storage, S3, just in case we want to reprocess that data later. And then there is a layer of orchestration here using Airbnb's open source tool called Airflow that helps us spin hundreds of instances in a day so that we can read all of this massive 10 terabytes of data, look for patterns, and then take actions on it. So at a very high level, this is a big data problem where we have to ingest a lot of data, then analyze it, and take an action. Because if we don't take action, bad stuff happens. Okay? So Airflow is the orchestration tier that we use. And let's take a look at our storage footprint now. We pretty much have leveraged any tiers that exist out there with S3 as well as EFS, because different sets of data, different use cases merit us to optimize the cost, the storage of this data. And on top of S3 EFS that I talked about, the nature of the surveillances that need to happen is at a very high level twofolds. There are certain bad actors we need to catch in real time. We cannot wait till the market closes at 4 to go after analyzing the data. There are some section of surveillances or manipulations that we need to understand when the market closes, but then there's a small subset of surveillances that we need to catch in the real time as they are happening. If somebody is manipulating the market, we cannot afford to take hours to catch that, find that, and take an action. So those kind of analysis or data queries had to be run on the Elastic Block Storage, EBS, on the EC2 instances. And then we use RDS as well heavily for some of our transactional data, some of our web dashboards that the analysts use to read the data or to decipher more into the data. Everything is encrypted at rest using KMS. Not gigabytes, not terabytes, 7+ petabytes of data in close to 2 years. Massive, massive scale, close to 15 million objects now and counting. So that's the scale of storage. And like I said, if something happens to one region, any storage tier in one region, we have to be resilient enough that within minutes, we can operate out of a different region. So a lot of AWS's data sync capabilities were leveraged because we found out that normal copies, syncs, rsyncs were not as efficient as data sync is. Usually, we see a 10x speed benefit of using data sync versus rsync. And then we leverage S3 cross-replication to take the data from North Virginia to Ohio. And a lot of the different tiers of S3 are managed using S3 lifecycle management policies. Now let's talk about the compute, the second pillar that we had to keep in mind. So we've been talking about this number, 500 billion records in a day. I would like to draw everybody's attention for a moment. What does that mean, 500 billion records, right? Anybody sitting in the crowd, if they blink their eye, normally takes a human being 100 milliseconds to blink an eye. In that duration, if you right now blink your eye, this system that we've built in the cloud will be handling 2 million records. 2 million records. I come from an e-commerce background where I used to work with Alibabas of the world, Amazons of the world. And whenever we used to see that the equivalent of Black Friday in China, which is called Singles Day or Double 11, way bigger than Black Friday in North America. Whenever we used to see scale of 30,000 orders in a second, we used to do high fives. And here, in a second, this platform does 20 million records. 20 million records in a second. So that's the scale we're talking about, not only about the storage, but also how do we leverage the compute capabilities, what kind of capabilities we have to really do a decent job or a good job to capture that data, to analyze that data. There isn't an availability zone out there in North Virginia or Ohio that we haven't leveraged for this because capacity is a big deal. We cannot afford to be running in 3 availability zones only to find out that somehow at that moment we couldn't capture the spot instances or on demand or reserved as well. So we've leveraged all the availability zones that exist in both the regions. And I think we've beaten this horse to death when it comes to instance types. Multiple types of instance families, multiple types of permutations, combinations have been used in order for us to get the most bang for our buck. We just don't go with one or a couple of types of instance families based on the workload, based on the time of the day, based on the use case. We've leveraged dozens and dozens of instance types based on the use case. And then we use a bunch of serverless Lambda functions as well for the compute capabilities. When the data comes to our cloud layer, we have a C++ layer that is modified, optimized so much that, again, the horse has been beaten to, maybe death is not a good word, but we've done pretty decent job in optimizing OS, optimizing a lot of layers to make sure that we can handle this kind of volume. Orchestration. This is the piece that does all the magic for us. From the very beginning, we had the goal of not doing any manual clicks, not waking anybody up at 3 in the morning, which, by the way, sometimes happen. We are not perfect. But our goal was, hey, let's code everything. We built web applications, we built mobile applications, and we know, we come from a background where everything has to be tested, everything has to be coded was the philosophy. We took that to a whole new level with our cloud infrastructure. Anything that gets deployed to the cloud is not only coded. Right now, we use Python and Terraform a little bit. But everything is tested, runs through proper checks and balances. So when we started the project, CDK was still in the nascent stages. I remember those days when we used to find, apparently CDK was very famous in Japan, and there used to be blog posts in Japanese about CDK, and we used to copy and paste it in Google Translate to understand what they're talking about. But we are very happy with the service CDK. It has taken our development teams, and it's basically steroids for doing an IAC job well. And then we use some Terraform as well to keep the engines running. Airflow, like I said, Airbnb's open source platform that we use to orchestrate all of that. Imagine you have to manage, worry about, look at the status of hundreds of servers in a day. How do you do that? It's not humanly possible to be tracking everything manually or through web or dashboards or even the consoles. So highly, we really like this piece of platform in our platform, Airflow. And then on a typical day, we are working with about 150 to 200 instances, different instance types on a daily basis with a lot of Lambda in between, a lot of serverless as well. Now talking about, so those were the three pillars, right? Compute, storage, compute, and orchestration. Building a system this scale obviously comes with a lot of learnings, and we are quite glad we took this journey, and we are where we are, and we're not going to stop, definitely. This is our first time at reInvent, presenting at reInvent. Quite grateful to be here, but it's definitely not going to be our last, for sure. So one of the very insightful lessons that we learned while building this platform was we started with obvious choice of using S3 while storing the data or building the platform. And the S3 had to be used in a distributed fashion that all of our compute should be able to access the storage to read, write at the same time. And we use this service called S3 Storage Gateway in order to do that. But again, it's great. It works for many use cases, Storage Gateway. But the latencies that we needed, the throughput, the I/O that we needed, we realized that there were a lot of cache misses that were happening when we were trying to write and read the data at the same time in a distributed fashion. So we worked with our AWS partners, EFS team especially, to come up with a better alternative to do more real-time data analysis using EFS tier. How were we able to change the wings of the plane while it was flying was, again, bringing back the point home, the CDK and Terraform. Everything is coded, everything is tested, everything can be repeated. That helped us change the wings of the plane, like moving from storage gateway to EFS, a lot of optimizations for instance types, all in very agile fashion. And we started our journey, I believe, with 5 availability zones, but quickly moved to 9, all while the platform is up and running. Can't stress enough about how amazed and how how much benefit we've reaped from the concepts like IAC. And the real beauty that we felt, or the real magic that we felt, was that our development teams didn't have to be taught how to work with Go language. They didn't have to be taught how to work on YAMLs or CloudFormation. None of that business, right? Because the way we look at industries moving in such a way that the separation of infrastructure from development is kind of receding, for good or worse, but it's receding. And we wanted to really leverage our teams where they are best at. Let's say a team is good at Java. OK, bring your own flavor of development. But CDK kind of tools allowed our development teams to say that, OK, we are new to cloud, but we are not new to Python. And that's what the magic was all about. We didn't have to train people for months to start hitting the ground running, because they know PyUnits, they know JUnits, they know how to access a file in Java very well. And we said, OK, you don't have to learn Go to do a simple thing. You know Java. Let's code in Java, and let's get the job done. So this was a good learning for us. Then, because of some of these architectural updates, it's a massive system. We've been running it for close to 3 years now. And there have been a lot of changes that this platform has gone through, from cost optimizations to compute optimizations to storage optimizations, you name it. I used to think I know cloud a little bit, but after working on this project, I had a whole more appreciation for cloud. So what happened with all of these lessons learned, like changing the storage gateway to EFS or using different S3 tiers and making it work? We are very proud to say that already we were quite cost optimized. I'm sure a lot of folks in the crowd know about Spot instances, we introduced Spark instances pretty early in the cycles and saw a drop of anywhere from 70 to 90% in our compute costs. So we were doing fine. We were not bad. For first project of this scale, we were not bad. But in the last 6 months, because of the partnership that we have with, and I'm not saying this because I'm standing here on a stage provided by AWS. I really mean that we have a really good relationship with folks at AWS. And just in the last 6 months, for a platform of this scale, we've further reduced the cost by 40% by using a lot of techniques in EFS to S3 and Spark instances, right sizing of the instances. And also, not only were we able to reduce the cost, but also now we process the data faster as compared to day one. And things like our great networking team. Where is James? Anybody? James? Where's James? Oh, James is here. Yeah, James from our networking team was a great partner all the time. And we expanded the bandwidth that we have between our on-prem and the cloud. The direct connect capabilities were expanded, in fact, doubled. So all those things collaboratively or collectively helped us a lot in cost as well as making the platform faster. Remember, the blink of an eye, and we are done with 2 million messages. Quite a, again, not trying to be snobbish, but that's quite a, engineering feat in my opinion. The graph on the right shows, the top graph shows costs reducing in the 6 months. The bottom two graphs show that. The graph on the left, bottom left is our S3 costs reducing even though our footprint or the number of objects or the storage on S3 was increasing. We were still able to reduce the cost. Yeah, so we're very excited about what lies ahead, not just what we've done so far. And, we are quite grateful to be here as well. Like I said, we'll be back for sure with more stories to tell. I also wanted to take a moment out and, dedicate this presentation of mine to my family back home, especially my lovely wife. It's because of them that I am who I am. And also my amazing team that's sitting here, because without them, this wouldn't have been possible. So thank you so much. If you have any questions, come see us after the session. I'm bringing back Anand to talk about where we are headed next. Thank you very much.
Thanks, Benil, for covering the AWS side of things. So we did the migration, right? We finished the migration, but our journey doesn't end there. So we spoke about our storage optimization. We introduced EFS. What it did, it introduced additional cost for us. Now, it was much higher than what we originally anticipated. So we were working closely with the AWS team. And this week, there was an announcement about EFS one-day lifecycle change. That change was introduced to us slightly ahead of time so that we can further reduce the cost. They also announced elastic throughput that is going to have better performance and much lower latency for read and writes. So we are going to see better performance by EFS going forward. However, we are constantly in the lookout for better storage and file systems. We are looking at FSI clusters and some other file systems also. Now that our day-to-day operational issues were not there anymore, we could focus more on the analytics of the output that is generated. There are exceptions generated. There are alerts generated. There are a lot of manual activity that happens after the fact for analyzing the data that is generated out of the system. So we are putting together sophisticated analytics using AWS QuickSight. And that is very helpful for the analysts right now to further their analysis process. QuickSight also announced asset management. So with that, the asset which is there created by one of the developers can be shared with other developers. We are also right now looking at AI and ML with SageMaker. So with such a big migration, right, we have a lot of learnings. I will touch upon few key points as takeaways from this session. At a seasoned organization like NYSE, there are always established processes and policies, procedures, you name it, right? So when we were thinking about cloud, there were adjustments needed from various groups: system engineering, network engineering, system operations, IT compliance, release engineering, you name it. Everybody worked together, came together, changed their policies and procedure, made sure that the project is a success. However, it needed a cultural shift for the company. And I cannot stress upon how important it is to have support from the senior management for this. I would like to thank two persons here, Sridhar Masam, CTO NYSE, and Mayur Kapani, CTO ICE, who constantly guided me and supported me every time I faced a challenge. They were there to help and bail me out of that. So without the support from senior management, an initiative like this for an organization which is seasoned like NYSE wouldn't be possible. As an organization, we learned a lot out of this exercise. We are much more comfortable right now with cloud initiatives. And because of that, when there was a customer demand, we migrated our historical NYSE trades and code product to S3 recently. And we are here, our team members are here to listen to any of you guys. If you need any other data set or any other services product, please reach out to us. We also migrated our corporate data archival to S3 recently. So that's a big cultural shift and organization change that happened for us. Now, Vinil touched upon a few things about flexibility that we have with the cloud. So with the flexibility, the team is able to innovate. They are able to utilize different kind of EC2 instances, different kind of storage classes, different kind of services that is provided by AWS to further optimize the system. And we are always aiming for having 100% automation testing. So that really helps to have this flexibility in the cloud. You can spin up a machine, you can run a test, you can shut down, tear it down as we go. The other thing I would like to mention is that this was not just a journey for our technology, but every aspect of the system had to be considered. Like we look at our on-prem deployment, from technology compliance point of view, security, Reg SCI requirement, we look at the cloud deployment with the same lens. So we had to develop that thought process also. Lastly, I would like to mention one thing. So I had the rough idea that cloud would solve this big data problem with the scalability that cloud provides. But initially, when I was thinking how to go about it, with the help from my senior management, we focused on getting the right people into the team. Vinil came into the picture with his expertise on cloud computing. However, there is one aspect that I cannot undermine, is training the existing staff that is there. They have the domain expertise, so we heavily invested in training them with cloud computing. Automating each and everything, writing test cases, it made the life difficult for the team to make sure that there are test cases and automation, repeatability, you name it, everything should be automated. That required a thought process change. That required investment in training and certification. But it cannot end with the initial training. That needs to continue, and it should be a continuous process. And as the quote says from the Fellowship of the Ring, There are enough abuse in the financial world similar to the real world, but with the right technology, we can make sure things are running in order. With that, thank you for having us here, and we are here for any questions after the session.